Hello everyone and welcome back. My name is Mr. Cobalt, and in this video we're going to go over percent ionization of a weak acid. So let's get into this. So what is percent ionization? So percent ionization is where you take the concentration of your ionized acid and you divide that by the initial concentration of the acid you're given, and then you multiply by 100. So anytime you find 8% of something, it's always going to be like the part of what you start with divided by the whole that you started, or I should say this. So it's going to be the part of the whole. So you're going to have a part divided by a whole multiplied by 100. So the part here is the concentration of the ionized acid. So how much of the acid was ionized? That's what's going to be the part of. So not all of it is going to ionize because it's a weak acid. If it was a strong acid, it would be 100% ionization. So part of it will ionize. So that's the concentration of the ionized acid. And then the initial concentration of the acid we started with is our whole. And we're going to multiply that by 100. And what that comes down to, if we're dealing with a monoprotic acid, which for the most part we would be dealing with that, is that the H plus concentration, or the hydronium ion concentration at equilibrium, is going to be the same as the concentration of the ionized acid. That is only true for the monoprotic acids. If it's a diprotic or triprotic acid, that is a weak acid, that gets a bit more complicated. So for a monoprotic acid or monoprotic weak acid, we can take this as the concentration of the H3O plus concentration at equilibrium, and the the concentration of the acid initially started with, and then we multiplied that by 100. So let's go over a couple of examples, and we'll point out some key things here. So let's say we have a 0.2 molar solution of HNO3, which is a weak acid, and we find that that weak acid for this concentration will give us at equilibrium 9.6 times 10 to the negative 3 concentration of our hydronium ion. So we can take that and calculate our percent ionization. So the percent ionization of this acid at this concentration is going to be the H plus concentration at equilibrium, which is the 9.6 times 10 to the negative 3, and divided by the HA concentration initially, which is our 0.200 molar. And so we take the 9.6 times 10 to the negative 3 molar, divide that by 0.200 molar. The molarities cancel out, multiply by 100, and we get 4.8% ionization. So here you can see that a relatively strong weak acid, it's a weak acid, but it's relatively strong. It's one of the strongest. Even with that acid, you only get 4.8% ionization. What that means is you have, out of 100 molecules of HNO3, less than 5 of them are going to actually ionize in water. So it's still pretty weak. So what happens if we increase the concentration of this acid? So instead of 0.200 molar, we start with a concentration of 2.5 molar. And so we find with that molarity that the concentration of our hydronium ion is now 0.034 molar. So you can see with a higher concentration, you get a larger concentration of hydronium ion. So here we had 9.6 times 10 to the negative 3, but with a higher concentration of the same acid, but a greater initial concentration, we end up with more H plus ions in solution. So more of this is going to ionize, or we get, I should say, more H plus concentration. But let's calculate the percent ionization. So the percent ionization, again, is the concentration of our H3O plus ion at equilibrium, which is 0.034 molar. and then it's divided by the HA initial concentration of our acid, which here is 2.5 molar. So we take 0.034 molar, divide that by 2.5 molar. The molarities cancel out, multiply that by 100, and now you get 1.4% ionization. So you'll notice that even though when you increase the concentration, the initial concentration of your acid, you do get more H plus produced when you increased the molarity or concentration of your initial acid, but you'll notice that the percent ionization decreases. What that means is that the increase in the amount of H plus that is produced is not a linear progression. So just because you put in more acid, you start with more acid, you do get more H plus ions produced, but not as much as you would when you have a dilute solution. So here you can see that more concentrated solution of the acid means that you have less molecules ionizing per 100. Well, why would that be? I'll explain that in just a moment, but here are the two key things we want to point out. So one, as the concentration, we'll see that the concentration of our H plus ion at equilibrium of a weak acid increases as the concentration of the acid, the initial concentration of the acid increases. But the percent ionization of the weak acid decreases as the initial concentration of the acid increases. Well, why is that? And we can we can understand this by using Le Chatelier's principle as an analogy. So here's our generic equation for the ionization of a weak acid. So we start with our weak acid HA, and that's going to be in equilibrium with H plus and A minus. So think of this in terms of the concentration of the acid and Le Chatelier's principle. So think about what if we have this at equilibrium and we increase the concentration of our acid, right? What is that going to do? So if you increase the concentration of the acid, the higher concentration of the acid is going to create, it's going to shift to this area here. So it's going to reach a new equilibrium. So you're going to end up generating more H plus and more A minus here. So that's going to cause an increase. But even though you have an increase in this, you're not going to get as big of an increase because of or an increase in your ionization, percent ionization, because the shift is going to be towards the place that has more ions. So for example, if I have more ions here, or not ions, so if I increase the amount of particles here, you'll notice that this side has more particles than this side. So if I increase the amount of particles on this side, right, then what's going to happen is it's going to shift in the direction that wants more particles or less particles, right? So if I increase the concentration or increase the particles here, then it's going to move in the direction to kind of try to decrease that amount of particles. So if this side has more particles, so I have 2 particles on this side, and I have 1 particle on this side, and I increase the amount of particles in solution, it's going to shift towards the side that has less particles. So it's going to shift in this way, right? So you can see that the greater number of particles that I'm putting into the solution, it's going to kind of switch. You would expect it to switch in this direction to decrease the amount of particles. So more HA would stay together at a higher concentration relative to these being formed versus at a lower concentration with less particles, then it would kind of shift to make more particles. So you can kind of see or understand the decrease in the percent ionization when you increase the concentration. So if you think of it in terms of number of particles, more concentration means more particles. So it's going to shift towards the direction of not having so many particles, which means that it wants to have more of this side, the HA, than having the two particles together, and so that's going to decrease the relative amounts of H plus versus HA. So your ionization percentage will go down, even though your H plus concentration is going to go up because you just have more acid. So having more acid is going to just logically make the H plus go up, but the percentage is not going to be the same because it's going to want to shift towards making keeping more of this. Okay, so I hope that was helpful. If you like this video, please like the video, subscribe to my channel if you want to get more of my videos, be notified, hit that notification bell, and then also put a comment in the comment section. Let me know what you think. Ask me some questions if you have them. Thanks for joining me. Have a great day.